Question 6, okay? The particle is projected with speed 10 meters per second at an angle tan inverse 4/3 to an inclined plane. Excuse me. If the plane makes an angle tan inverse 5/12 to horizontal, find the terms in terms of g, the time at which the distance travelled parallel to the inclined plane is twice the perpendicular distance above the inclined plane. Alright, an interesting one, okay? So, even when you don't understand the question initially, you're just going to write down your 4 formulas, you're going to pick up about 50% of your marks, and then you're going to figure out what you're doing, okay? So, these questions always start the same way. We're going to have a gradient, and this gradient I'm going to call beta, isn't it? And we have a thrown angle, which we'll call alpha, and then it lands somewhere up here. Okay, we start off by finding out what I'm going to start by working on both angles straight away. Beta is going to be my tan inverse. So beta is going to be tan inverse 5/12, which is 5 for the opposite, 12 for the hypotenuse. Makes it 12 for the adjacent, 5 for the opposite. Makes it 13 for the hypotenuse. I now know that sine beta is 5/13, and cos beta is 12/13. Next thing, I'm going to say that alpha, the thrown angle, is tan inverse 4/3. So this is going to be alpha up here, and we're going to have 4 as the opposite, 3 as the adjacent, 5 as the hypotenuse. Therefore sine alpha is 4/5, and cos alpha is 3/5. I'm now go about creating my equations, but before I do that, I'm going to make the gravity triangle. Okay, so gravity triangle will now be done in green. Okay, and here's the gravity triangle, like so. Now, this is breaking up gravity into components parallel and perpendicular to the inclined plane. So, we all know that this angle here is beta, right? It's been beta every time. It's always the angle of the wedge. Okay. This is gravity. This is g cos big, and this is g sine big. Now, what is g cos big? G cos big is 12/13g, and g sine big 5/13g. So we've broken that up into our components, okay? Now we're going to look at our thrown angle, u. So u is getting thrown up at an angle alpha, and what we're going to figure out is what is the, we threw it up at 10, so this is all initial velocities, so we want to find out what ux and uy are. So ux is going to be 10 cos alpha, and uy is going to be 10 sine alpha. What's 10 cos alpha? It's going to be 6, because 10 times 3/5 is 6. 10 sine alpha, 8. So it's going 6 across and 8 up at the beginning. Now we're going to use our two formulas. V equals U plus AT. So, start off with Vx, guys. What are we dealing with Vx? Somebody call out the first number for me. Vx? Anybody? In the Vx direction? 6. Because 6 is going this way here. Remember, ux is this direction, uy that direction. Okay? So ux is 6 minus gravity times time. What's the gravity working against it? 5/13 gt. Vy, anybody? Vy? 8. Yeah? Minus 12/13 gt. Alright, what's a quick conversion from Vx into Sx? How would you go about doing it? Add a t, half the second fraction, which is going to turn it into 5/26, and then add a t on, which is gt squared. Okay? And what about sy? Same thing. add a t onto the 8th, half the second fraction, so it becomes 6 over 13 gt squared. Now you've done that, now you're ready to read a bit more of that question, okay? It goes, the time at which the distance travelled parallel to the inclined plane is twice the perpendicular distance above the inclined plane. So, look at this, okay? An example would be, I'm going to shade this in yellow. Imagine this is the SX distance, yeah? The SX distance, roughly, just roughly around there, yeah? And then what's the SY distance? There we go. So, fix this up. Do you see on this one that the yellow line is roughly twice the green line? I'm looking for that to happen. Okay? So, in effect, my formula is basically this. SX equals 2 times SY. That's all you gotta do. SX equals 2 times SY. So, I'm gonna rub out my diagram. Diagram is no longer needed. And I'm just going to put in this equation here. So, what we're going to get is Sx is 6t minus 5 over 26 gt squared equals 2 times s of y. So I'm going to multiply everything here by 2. Alright, and what are we going to get? 16t minus 12 over 13 gt squared. Going to move everything over one side. So I'm just going to be really cheap about this. I'm just going to get 12 over 13, and I'm going to take away 5 over 26. Whatever that comes to. 19 over 26, okay? So I'm going to bring this over to your side. I'm going to get 19 over 26 gt squared. The 16t comes over to your side. Take it away from 6t. Was it? Minus 10t, right? Okay. Equals 0. I'm going to make a quick adjustment to the 10t. I'm going to turn that 10t into 260t over 26. Is that right? 260t over 26? Yeah. Because I just want to give them the same denominator. I just think it's convenient to do it now. 26s are gone. And we are going to take out t only. So we're going to be left with t bracket 19 gt minus 260 equals 0. T can equal 0, or what else? 19 gt minus 260 equals 0. T 19 gt equals 260. T equals 260 over 19g. That's the time we got in terms of g. Okay. Here we go, guys. Number 7. Excuse me. Particle is projected at speed 4 √5 ms at angle tan inverse a half to the inclined plane. The plane makes an angle of 45 degrees with the horizontal. The particle is projected along the line of greatest slope. This means it's thrown normally, okay? Show that the speed of the particle when it lands is 4 meters per second. Now, let's zone in on exactly what we want here. Its speed is 4 meters per second. Imagine this. I'm going to zone in like a magnifying glass on this here, okay? I'm going to make up, this is what's called a simplified method of maths. You make up a really simple way. Like you make the question overly simple and you see what you'd have to do to make it work if you knew everything already. So an example would be my phi x, just as it hits the ground, and it's coming in at this angle here, okay? Just as it hits the ground, its phi x is 5. Is this phi y going to be positive or negative? EY, anybody? Going to be positive or negative? Has to be negative. Can every time EY? Remember, phi y is in this axis here, which means it's got to be coming down into the plane, and phi x is going in this direction here. Your overall speed is a combination, your overall velocity is a combination of phi x plus phi y. An example would be if phi x was equal to 5 and phi y was equal to minus 4. Your overall velocity would be 5. If you want to call that I, you can, even though technically it's not I because there's a new xy axis here, okay? But it'd be something equivalent to phi y minus 4j. 5 across for every 4 down, with the plane as the x-axis, okay? Now, if you want to get the speed of that, how would you get the speed of that? You do Pythagoras' theorem and you find out its speed. So what we're going to do is we're under the same, we're using the same system here. We're going to find out at the time of flight, we're going to find out what phi y is. We're going to find out what phi x is. Upon finding out what phi y and phi x are, what we're then going to do is we're going to do Pythagoras' theorem, which is this guy here, to find out what the overall velocity or speed is. Does that make sense? Now, so we take a wild guess at what we're going to do for the first 5 minutes of this question. We're going to make all 4 equations again from scratch. Okay? So, beta this time is 45. So you can actually just look it up in your tables if you want. Tan beta is 45. Oh, sorry. I got that completely wrong there. Beta is 45. So, tan 45 equals 1. Sine 45, 1 over root 2. Cos 45, 1 over root 2. Next we're going to work with the Landon angle. The Trone angle is angle alpha. So let's work with alpha here. You ready? So, alpha is getting thrown up this direction here. That's going to be alpha here. It's going to be a 1:2. Root 5. So now we know that cos alpha is 2 over root 5. Sine alpha is 1 over root 5. Everybody happy with that? Okay. Upon completion of that, we're now going to go after phi x and phi y. Okay. Phi equals u plus at. Now, I haven't done my gravity triangle yet. Once again, your gravity triangle, it's always the same angle as the inclined plane. 45 here, full extent of gravity going straight down. What is this one going to be here? G sine 45, which is the same thing as G over root 2. Where did I get G over root 2 from? I multiplied sine 45 by G. This part here by G. And now I'm going to multiply cos 45 by G. G cos 45 equals G over root 2. So we have both G's over root 2's there. Now, we're going to construct our equations. Okay? So, phi x equals what, lads? Have I done the Trone part yet? No, I have not done the Trone part yet. I got to break up my 4 root 5 into its 2 components. 4 root 5 must be broken up into your initial velocity along x and your initial velocity along y. Is that right? Now, this one is going to be 4 root 5. What we say that is alpha, isn't it? 4 root 5 sine alpha and 4 root 5 cos alpha. Excuse me guys, what is 4 root 5 sine alpha? Sine alpha is 1 over root 5. So you can replace sine alpha with 1 over root 5, and you can replace cos alpha with 2 over root 5. So what happens then? Multiply it out. Yeah? For which one? No, beta. the plane makes an angle of 45. That's the angle of the plane, not the angle of the throw. The angle of the throw is alpha, which is tan inverse 1 over 2, which brings you to this triangle here, where the hypotenuse was root 5. Cos alpha therefore is 2 over root 5, and sin alpha was 1 over root 5.
Oh yeah.
And I'm now using that over here for the throne.
Yeah.
For the throne. So the root 5's cancel, so it's going to be it's going to be 4 up and 8 across. Okay? Let's rub all this out. Wait, what did I do there again? Sorry, 8 across, 4 up. Everybody happy with that? 8 across, 4 up. It's basically a scale of 4. Now, okay. So what we get next, lads, is we're going to do phi x. Now, what's the phi x? What's the u along x? U along x, anybody? The u value for phi x? 8. Gravity times time, which is gravity value? G over root 2. And multiplied by t. What about phi y? 4 minus gt over root 2. Now, the problem with these two equations in the scheme of the question is, I need to find out what t is to find out a legitimate number for this. Okay? So now I'm going to find sx and sy. Once again, do what you did last time, add on a t, half the fraction, and add on another t. 2 root 2 gt squared. Okay? Same thing for the next one, add on a t, and then half it, so g over 2 root 2 t squared. So now our full every equation we need is now there. So I can get rid of all this. Anybody have a suggestion about how I'm going to do this question?
Sy equals 0.
Sy equals 0. Would you have another way of doing that? Yeah, you're right, by the way, but is there another way of doing it? Phi y equals 0, double your answer. 2 ways. We'll go for sy equals 0 because that's the more conventional way to do it. So, what we're going to do is sy equals 0. Going to get our sy equation. 4t minus gt squared over 2 root 2 equals 0. gt squared over 2 root 2 equals 4t. Let's cancel the t's. We're just, when we cancel the t's, what answer are we getting rid of? T equals 0 is gone. Okay? We would have got that answer, but now it's gone. Because look, at the end of the day, that's there, so that's not what we're looking for. Bring up the 4. T equals 8 root 2 all over g. Now that we have that, we're now going to plug that into the phi y and phi x equation. So we're going to expand it here. So we're going to get 4 minus g over root 2 multiplied by... Oh, yeah. I was just about to get that. That wasn't about to make sense at all because if x would have been negative, which means it'd be coming back down where it came from, which makes no sense. Like that can happen at a high enough angle, but this question wouldn't make much sense. Now, g over root 2 times t, which is 8 root 2 over g. The g's cancel, root 2's cancel. 8 minus 8? 0. Now that's very interesting. Do you know what that means? It means your phi x, there's no phi x at the point of impact. This means that it drops at 90 degrees. If there's any phi x, if phi x is positive, it goes slightly this way, away from the 90 degree angle. if Vx is negative, that can happen. It'll be dropping slightly that way, relative to the plane. Okay. Now what about Vy? So Vx equals 0. What about Vy? Vy is going to be 4 minus g root 2 all over t. T is 8 root 2 over g. Root 2's cancel, g's cancel. 8 minus 4. I say 4 minus 8. Minus 4. So it's hitting it at 4 down. What question says 7, was it? Yeah, that's right. So the speed as it hits it, because it's in one direction only, because Vy is 0 and that's 4, Pythagoras' theorem, it's no longer a triangle, it's a straight line. So the answer is 4. Or you can just put it in here and say, look, 0 squared plus 4 squared, square root of 16, or minus 4 squared more appropriately. Phi equals square root of 16, phi equals 4. So either way the velocity is 4. Okay.